All right, so this one we're supposed to repeat example 4, which is over here on the right, except we're supposed to change it to 6,000 flash drives per week. So what we've done is we've gone from 2,000 to 6,000. Everything else is the same, right? We have our cost equation, we have our revenue equation, we have our profit equation, and where the production output is 1 week is in 1 week is X flash drives, so that's our production. And the production is increasing at the rate of 500 flash drives per week when production is now 6,000 flash drives. So that's kind of the key difference here. And so now we need to find the rate of increase in cost, revenue, and profit. All right, so let's do A. We'll do it all the way up here. Well, A, we're looking at the cost function, right? So it's going to be C equals 5,000 plus 2x. And so we're going to implicitly differentiate this with respect to time. So if we do that, well, that becomes what? Well, that's going to be dc dt equals, well, 5,000 just goes to 0. And then we have 2, and then we have dx dt. Okay. Well, we said that dx dt is 500 flash drives per week. So that becomes 500. So that's going to be 2 times 500. And so that's going to be equal to $1,000 per week. So the cost is increasing at a rate of $1,000 per week, basically. So it looks like cost is increasing by $1,000 per week at what we're looking at here. Okay, so that was that one. Now we want to do revenue. So we're going to do the same thing, except now we're going to do it with the revenue equation. Well, how's that going to work? Well, that's just going to give us dr dt. So we know we're solving for that side. So the other side is going to be easy. We just have to take derivative of that's going to be 10. That's going to be dx dt. And then minus, and then we'll bring that 2 down. So it's going to be 0.002x dx dt. Now we just plug in what we know. Well, dx dt, we said that's 500. So that's going to be 10 times 500 minus 0.002 times 5, times, this time it's 6,000 because we have an x is 6,000. Then times the 500. Okay, so that one makes it a little bit harder. So now we have 10 times 500, so that's going to give us 5,000 minus 0.02 times 6,000 times 500. So that's going to give us, it looks like a negative $1,000 per week. And so revenue then is decreasing at a rate of $1,000 per week. All right, so that's going to be how that one works. Now we're going to do profit. Well, profit is going to be P equals R minus C. So what do we know? Well, we know dc, which would be if we took the derivative with respect to time. We know dr, because if we take the derivative of that with respect to time, that would be dr dt. And then we'll find dp dt. So we're not going to plug in all this stuff for r and c. We're just going to say, well, that becomes dp dt equals dr dt minus dc dt, which is just equal to a minus 1,000 we found, minus, and dc is 1,000. And so that gives us a minus 2,000 per week. So profits then is decreasing at a rate of $2,000 per week. That's when we have the production of 6,000 flash drives, and we're increasing the rate of flash drives by 500 flash drives per week. So if we think about that, how would that look? Well, if we think about that, that probably means we're on this downhill slide. And so, if well, we start over here and we increase the production, what's going to happen is we're going to come down here and our profit then basically is going to be decreasing. So it's going to be going down. So even though we're increasing one way, it's decreasing here. Whereas on the other side, if we started here and we increased, then our profit's going to increase as well as our revenue. So it depends on which side you're on, depends on what's happening. So we have to kind of think about that. And we'll see that here in a little while in the next section, I think, on elasticity. So that's kind of what we're going to come to, but that's why it's doing what we have here. So let's stop there and we'll come back for one more.